apply a better coat of paint. Well, that's what Alain Kornhauser said to do a couple of years ago in regards to what a city could do about its infrastructure to help with autonomous vehicles. Josh, it looks like you guys have that better paint. Why don't you tell us briefly what this phosphorescent paint is that we're seeing, and then we'll have a conversation.
The core technology of this paint is a rare earth-based taggant. It can be an inner optical material that has unique properties that we can tune to various wavelengths. So if you interrogate that material at one wavelength, it will send a very unique frequency back at the sensor. So we've been able to multiplex these materials to implement a lot of different information into current smart paint and turn normal road paints into intelligent paints.
And it goes beyond just driving, but the things you're doing for the blind are really amazing.
Absolutely. So one of the natural kind of offshoots of this technology has been this project for the smart paint for the blind, that we've equipped our sensors into the standard white canes that they use for visually impaired, and we've started marking these smart paints on public crosswalks, bus stops, so that as the user's going down the sidewalk into a specific area, they'll be notified via an audio or vibrational indication that's equipped into the cane that they're entering a crosswalk. And we can encode a lot more information into these paints to provide them with a lot more geolocation as far as GPS coordinates and what corner of a sidewalk they're on, whether it's a northwest, southwest corner. We can encode a lot of unique optical signatures into these paints that can be detected and it turned into information for those users.
What makes this really neat compared to the traditional way of telling someone where they are is you don't really have to dig up concrete and put in these domes, right? These bumpy things.
You don't need the traditional yellow pads, the 10G blocks, which they have been very useful. You see them all over the world being used, and they do impart some information. We really see ours as an improvement to these, and also kind of more synergistic technology to these current technologies that are out there. The big advantage that we see with our materials being able to actively give more precise resolution to where their current surroundings are. With the 10G blocks, you really get just a general information. When you look at GPS, no person would really walk down the street blindly following their GPS when it says turn left or turn right. You would have some hesitation. Our materials can work in coordination with GPS to help provide that resolution that GPS can't enable in urban canopies and other environments where you do have limited signal.
Yeah, it could help both the sighted and the non-sighted. But the other part that's exciting about this is it's not a big public works project, right? You're talking about just applying paint?
It's not going to change anything. The current methods of application of the paint is going to be the same. It can be applied in using all standard thermoplastic paints that every state has approved. Our material gets simply added as an additive. Nothing else changed in the process. The cost, the overall cost is minimal. These materials are very, very cost effective as far as sensitivity. You don't need to add much of them to the paint. We can detect at less than 1% of these materials into standard road paints that are available.
Well, so is your model then more of a licensing model than anything?
Licensing model, I think right now that's where we consider ourselves an R&D company, and we develop these ideas, and ultimately we have no plans of going into the thermoplastic road paint business. That's a different industry. So we are strategically partnering with various companies, but ultimately, yes, it is going to be a licensing model for this tech.
So you've got it out actually in streets in Columbus and some other spots, Tampa, I think you said. Yep. When do you think we start to see this commercially in other places?
Very soon. I'd say, within the next year, we're actively having conversations with the state of Delaware and a few other places where we're rolling this out. So, within the next year, you're going to see this actually being implemented as part of mostly smart city projects. It's not being part of the general road infrastructure upkeep, but this is much more oriented towards public safety. And so this is going to be a different avenue that you'll see it rolled out than the normal public maintenance of streets departments. And I think that's a big area that needs to be focused on when you look at autonomous vehicles and how they operate, especially when they are looking at the vision of how well the current lanes, the current road paints are marked, and the wear of those, and how they affect the vision of these current autonomous vehicles.
That makes sense. And I assume that you've got some cane manufacturers actually embedding into the IR lasers in their canes and so forth?
Well, we actually decided to take a different approach as far as the cane manufacturers. We worked closely with the Ohio School for the Blind on identifying really the best application and where this cane is needed and how the best way to implement it. And what we found is, the canes for every individual user is really almost customized. So and they're actually used very ruggedly and get switched out quite often. So what we've designed is a system that can be detachable and mounted onto any current cane system without implementing, you have to use this particular type of cane. So this is something that any type of marshmallow style cane or tapping cane can be easily we have a kind of plug and play system that can be snapped onto these canes.
Excellent. Well, I appreciate your time here and good luck with it.
Thank you very much.
Thanks, Josh.